Hey class, so today we are going to be talking about variation, which is our last type of word problems, and they're kind of special word problems because they have a special relationship between x and y. So the first type of variation we're going to talk about is called direct variation, and that's when y varies directly with x, meaning as x increases, so does y, and they do this at the same ratio. So that sounds really confusing, but the way I remember it is this. If I see the sentence that y varies directly with x, then that is going to translate to the following. This formula, y equals k times x. So let's talk about what that k means. That k is some number. So it might be y equals 5x, which just means that y is whatever the x value is times 5. So it's proportionally related. And we need that k value there in order to write the equation. And we're going to solve for the k value. So that k value will not stay the letter k. It'll turn into a number at some point in our word problem. So the way I remember to write the formula is to put a k right away. K right away. So that's what we're going to say every time we write one of these formulas. And then we talk about inversely, and this is just the opposite. So for direct variation, as one letter increases, so does the other. Well, with inverse variation, as one letter increases, the other decreases, and it decreases at a constant rate or a comparable ratio as well. So instead of doing k times x, which is what we do for variation, for direct variation, for inverse variation, we do k divided by x. It's literally the opposite of direct. So for direct, we do k times x, and for inverse, we do k divided by x. Now, also, the letters will not always be x and y. The reason why I'm using that is because this is the example. Y varies inversely with x would translate to this. Y varies translates to y equals. So whenever you see something varies, you're going to put an equal sign when you see the word varies, and inversely means divide. Divide the k value by x. The k is always on top. We put a k right away. And then if we talk about joint variation, honestly, the word problems will not really use the word joint. They will use the word directly. So these ones are pretty much the same thing. But joint just means that you have more than one variable. So y varies jointly with x and w would translate to this. Y varies is y equals, put a k right away, and then times x and times w. So it's like direct variation. Right now that might sound really confusing, but when we do the word problems themselves, it's not that bad. Before we start the word problems, we are going to do one example of just writing a sentence. So here it says y varies directly with x and inversely with w. I just made this example up, so if you want to pause the video and write this down, you can. Y varies directly with x and inversely with w. How I'm going to write that out is this. Y varies is where I put the equal sign. So y equals. Put a k right away. So no matter what, you're putting a k. That's going to be a constant that we solve for. And it says directly with x, so that's going to be times x, and inversely with w. You take the whole thing and divide it by w. So inversely basically means to divide whatever you have by whatever the letter is that it follows. So this is how I would write that sentence out as an equation. So here's an actual example. Example 1, I'm only going to do 3 examples with you on this video. So this says the pressure exerted by a certain liquid at a given point is proportional. And by the way, if you see the word proportional, that's the same as direct variation. Proportional. To the depth of the point below the surface of the liquid. If the pressure is 20 meters below the surface, I'm sorry, I read that wrong. If the pressure 20 meters below the surface is 70 kilograms per centimeter squared, Then find the constant of proportionality and what is the pressure exerted at 40 meters below the surface. This is all sounding really confusing, but it's not that bad. Start by writing the equation, okay? So the pressure exerted by a certain liquid at a given point is proportional. This is the varies part. So this is the equal sign. So pressure is proportional. I would write that like this. P for pressure equals, put a K right away. And what is it proportional to? It's proportional to the depth. So I would put D for depth. Okay, that's the equation right there. We're done. But I have to solve for K. The K is the constant of proportionality. So when it says that, that just means find the K value. Well, I'm going to do that using the last sentence of this problem. It says the pressure 20 meters below the surface, so this is actually the depth. So the pressure 20 meters below the surface is 70. All right, so plug and chug. The pressure is 70. I don't know the K value, but I know that the 70 happens at 20 meters below the surface, which is the depth. So if I divide over the 20, I can solve for K. So K is 7 over 2. Okay, so what this means is that the actual formula is not P equals K times D. The actual formula is going to be, from now on, P equals 7 over 2. Replace the K with the number you got times D. So now this is the formula that we're going to use to answer the next question. It says, what pressure is exerted 40 meters below the surface? Well, I'm going to use my new formula with my K value. Oops. All right. And I'm looking for the pressure. I know that the new depth is 40. So P equals 7 over 2 times 40. So 7 over 2 times 40, you can use a calculator for that if you need to. I like to just do this in my head. 40 divided by 2 is 20. 20 times 7 is 140. And the pressure's units are kilograms per centimeters squared. So that is the answer. All right, so we are now going to move on to example 2. All right, this is a little bit more straightforward. I like these problems where it sounds confusing, but it's actually, these are my favorite. It says, let y vary directly as x and inversely as the square of m and the square of r. Okay, that sounds confusing, I know. And then it gives you a bunch of numbers. If y equals 5/3 when x is 1 and m is 2 and r is 3, find y when x is 3, m is 1, and r is 8. Sounds terrible. It's not that bad. Let's write the equation first. So this is the first thing we're going to do. Let y vary directly. Stop right there. That means y equals. Put a k right away. All right? And it varies directly as x, so times x, and inversely, so divided by. As soon as you see that word inversely, it means divided by the square of m, so that's m squared on the bottom, and the square of r, and that's also going to be an r squared on the bottom. This is the equation. Now, in this problem, the next sentence, I know it sounds really confusing, but it's actually going to give you things to plug in for every single letter except for K. And that way we can solve for K. So it gives me the y. The y is 5/3. It will not give me the K, but it should give me an x. Let's see, did it? Yep, x is 1. M is 2. So plug in for m. And r is 3. Okay. So my first job is always to find that K value. Let's simplify a little bit here. We get 5/3. 1 times K on top is just K. 2 squared is 4, 3 squared is 9, and 4 times 9 is 36. So how do we solve for this? Personally, I would cross multiply. Don't hesitate to bring out your calculator if you need it. 5 times 36 is 180 equals 3 times k. And we could probably do this in our head. Sure enough, we get 60 equals k. Beautiful. Now that's not the answer, that's just that k value, that constant value. So my new formula is now y equals, replace the k with the 60. 60 times x over m squared r squared. So we are now going to use this new formula to actually answer the question. It says find y, this is the last part, find y when x is 3. So y equals, use the formula with the 60 in it, x is now 3, m is 1, and r is 8. So you could literally just type this into your calculator. 60, oops, that's not what I wanted. 60 times 3. So we can just write that's 180 over 1 squared times 8 squared. So that's going to be 64. And so my answer is 2.8125. Okay, I could have even typed it like this. 60 times 3 over 1 squared times 8 squared. And gotten the same answer if you really want to type it out exactly the way you see it on paper. There's a couple ways to do that. All right, that's the answer, 2.8125. So moral of the story is we write the equation, we solve for k, and then we plug in the other numbers they give us to actually answer the question. We got one more example together, and then I'll let you loose on the homework. All right, this says the period of a pendulum varies directly as the square root of the length of the pendulum and inversely as the square root of the acceleration due to gravity. Let's write that equation first, and that's part A. It says write the equation. Okay, the period of a pendulum varies directly. So I'm going to do P for period. And varies means equals, and it says directly, so I'm going to put a K right away, times whatever comes next, because directly means to multiply. The square root of the length. So square root, I'll do L for length. And inversely, that means now divide. Inversely means divided by the square root of the acceleration due to gravity. So let's do the square root of A for acceleration. Okay, that's the equation. But now it says to find the constant of proportionality. The constant of proportionality is K. So I'm going to find the K value. That's my next step. And they should give me something to plug in for every letter except for K. That's how we find K. Let's see if they do. The period is 6 seconds. That's the P. Let's see, do they give me an L value? The length is 289. So I plugged it in here, so there's a square root around the 289. And the acceleration due to gravity is 980. So it's square root of 980, because it's the square root of A. Beautiful. So I have everything except for K, which means I'm going to solve. So I personally would take the square root of 289, which is 17, divided by the square root of 980 and get a decimal for that. Okay, so this is what we have. 6 equals, so this came out to be the decimal 0.543 times k. So all I did was type this square root of 289 over square root of 980 in my calculator, okay, to get that decimal, and that's where this is coming from. Just going to be the easiest way to solve for k. This doesn't come out nice, that's okay. So I'm going to divide both sides by that 0.543. Six divided by 0.543 is 11.05 equals k. That's part B, solving the k. So now I'm going to write for part C my new formula. My new formula is P equals, and instead of k, I'm going to write 11.05. Because I just found k, and then times the square root of L over the square root of A. All right, so now I'm going to solve the problem. The problem says find the period, so I'm looking for P, when the length is 121 and the acceleration due to gravity is 980. So the length is 121 and the acceleration due to gravity is 980. All right, so I'm going to take 11.05 times the square root of 121. You might know in your head that that's 11, but you get 121.55 divided by the square root of 980. And I would just take that in my calculator. And that's 3.88. And the period is the time, so that would be seconds. That's the answer. All right, so those are the 3 examples I'm going to do. So the deal is this. You start by writing the equation, okay? Directly means to multiply, inversely means to divide. You then find your k value by plugging in a number for every letter except for k. All right, then you solve for k, you get k by itself, and then you use that k value to actually answer the main question. All right, I can do examples 4 and 5 with you guys in class, but the ones that you're going to be doing on your homework are more similar to the 3 I just went over. On your homework, I'm going to require the evens. Okay, the odds are optional, and if you look at the evens, it's a lot like the second example we did. So hopefully it's not too crazy. The last one is a little bit more similar to the last example we did. And if you're feeling good about it, I highly suggest you do the odds, but I'm only requiring the evens from you. So that's what I want you guys to work on now. All right, thank you for your attention today. Hopefully this lesson wasn't too bad, but we can talk about it when I see you next.